By some measures, C is the most popular programming language in the world, and it came out almost 50 years ago. Today we'll get into the history and impact of this very important programming language. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, Dave, let's dive into C, the programming language. Let's start at the beginning. Who developed it and when?
In a previous episode, which I'll link to in the show notes, we talked about the Unix operating system. C's history is tied to Unix. Originally, C was developed by Dennis Ritchie, who was one of the two creators of Unix. He had worked earlier on a programming language called B, which was specifically a language to be used with Unix, and he worked on that with Ken Thompson, who was his co-creator of Unix. So then he wanted a language that they could actually use for writing Unix itself, because the earlier versions of Unix had been developed in assembly language. And if you don't know what assembly language is, I'm again going to link to you one of our earlier episodes in the show notes about what is a programming language. But basically, assembly language is the lowest level human-readable form of code that is just above what the machine speaks, which is machine language. So it's a really low-level way of programming. Dennis Ritchie wanted a higher-level way of writing code that could easily be translated into machine code. And so that's where C came from. It came from the evolution of this earlier language B and the want to be able to redevelop parts of Unix into a higher level language than assembly language. So in 1973, he worked on C, and it came out that year.
So C is one of the most popular programming languages and ranked as such. Who's doing the ranking and why is it so popular?
There are a lot of different ways of measuring programming language popularity. Probably the most popular is called the Toby Index, and I don't know if its methodology is really the best, but it's cited in so many different places that I'm going to cite it here too and put it in our show notes. By the Toby Index, C is the most popular programming language in the world. But if you look at any of these other rankings, it's going to be right up there, top 3, top 5, depending on which specific one you look at. The reason it's so popular is that it's used in many, many low-level areas. So we mentioned Unix already, and that's operating system development. And a lot of common operating systems are developed in C, whether it be Linux or Mac OS or Windows. Big portions of those operating systems are developed in C. A lot of low-level system libraries and a lot of low-level device drivers are also developed in C. Also, other programming languages tend to be developed in C. For example, Python, which is also a very popular programming language, its most common implementation is known as CPython. If you go to python.org and you download Python, you get CPython. CPython is a version of Python that's developed in C. So that means the people working on it are actually writing the code for the Python interpreter in C.
What makes C so useful? Like, why did they choose to write the Python interpreter in C?
So what makes C so useful is that it's a low-level language in the sense that it's really just a little bit above assembly language, but it's still high-level enough that it really makes programming a lot easier than assembly language. And its performance is very, very good. So most compilers today will take C code and translate them into machine code more efficiently than if a human being goes and handwrites the assembly language. So C compilers today, because there's been almost 50 years of development into them, are very, very good. Of course, programming languages also have a bit of fashion to them. So just because C is popular, it continues to be popular. There's a part to that because people who have already written code in it before are going to want to write code in it again. And if you're coming into this field and you want to, let's say, be somebody who works on operating systems, when you go work on someone else's code that already exists for an operating system, it's probably going to be in C. So the reason for programming language popularity is partially functionality and what they allow you to do, and then it's also partially network effects. And just because something is already popular, it tends to continue to snowball and be popular.
C was developed in 1973. How has it changed over the last half a century?
So there's been a couple major revisions of C. One was a standardization. Now, a lot of programming languages go through a standardization process. This means that there's a specification for the language that describes it in such a way that other third parties and the original creators could really go and re-implement it, and that compiler or interpreter that's re-implemented would be compatible with the original. This is important so that a programming language isn't just controlled by one entity. So C was standardized by the ANSI organization in 1989, and there were some changes to the language that are probably beyond and too detailed for our podcast today, but that was one of the major standards still to this day, and that's sometimes known as C89. Then there was a committee formed to continue to work on C and improve it, and they came out with another standard for C called C99 in 1999. And that was really the last major revision. There are some more minor revisions since then called C11 and C17. They're working on another revision that's going to probably come out later this year. The reason that C is so stable, a lot of programming languages change a lot more often than what I just described, is because it's used in such important applications. It's used for such low-level applications. There needs to be stability. We can't have a rocky foundation to our operating systems. We can't have constant changes happening to the language that's used for our device drivers. There has to be stability at that layer of the stack. And so C tends to be a very stable language, with the committee thinking, how can we maintain backwards compatibility and make some very small changes to improve programmers' lives, rather than weighing it the other way. Some programming languages think more about, how can I improve programmers' lives first, and think about backwards compatibility second. C is all the way on the other side of the spectrum. It's all about stability and maintenance and keeping things compatible.
How is C related to C++?
C is a small language. It doesn't have that many features, and it really only allows you to program in one style, which is called procedural. And again, in our previous episode, What is a Programming Language?, we get into that a little bit more. But basically, in a procedural programming language, you organize your code into subroutines, which are sections of the program that can be called or activated from other parts of the program, and then you can return control back to the area that called them. That's a pretty simple way of organizing a program. There are much more sophisticated paradigms such as object-oriented programming, functional programming, logic-oriented programming. The most common paradigm for software development today is object-oriented programming. And object-oriented programming, instead of thinking about just organizing things into procedures, you think about abstractions called objects, which can model entities from the real world. For example, instead of having some code that says, this is how you turn on the car, this is how you make the car go forward, this is how you describe how to make the car turn left, you might actually have an object called car. And that car might have some properties, such as how many wheels it has, what manufacturer it has, who is the driver. And it might also have some actions, which are such as turn left, turn right, go forward. So we think about the car as a unit, instead of thinking about the discrete pieces of code that might manipulate what the car is doing. And so object-oriented programming is a really powerful concept. It really allows us to think at more of a human level in terms of our programs, instead of just thinking at the code level. And so object-oriented programming quickly became popular when it came out in the 70s and 80s, and people were thinking, how can we make a language that is compatible with this very popular language C, but adds object-oriented features, because C itself does not have object-oriented features. And the main language that came out of that thinking was C++. And so C++ comes out in the 1980s. So does another language called Objective-C, which also tried to add object-oriented features on top of C in a different way. And probably getting into details of one versus the other is a little beyond the scope of our podcast, but C++ is the one that really took off in popularity. Objective-C was really only used by Next, which later got purchased by Apple, and so is used as the foundation for a lot of Apple's frameworks in their operating systems. But C++ got used pretty much everywhere else and became popular throughout the programming world.
How has C impacted other programming languages like Java or C# or Python?
So while C++ and Objective-C are both largely backwards compatible with C and are mainly supersets of C, adding additional features on top of C, many other programming languages still got influenced by C without actually being explicitly backwards compatible. The reason being is that they wanted to tap into that large number of programmers who already knew C. And so therefore they wanted to adopt similar syntax, which is basically what a program looks like, so that programmers would feel comfortable in those languages. And so some of the most popular programming languages today, such as Java and JavaScript, have what we call C-like syntax, meaning that they superficially look quite similar to C. In fact, some small pieces of code you could take from C and put into C++, Objective-C, Java, and JavaScript, and they would all basically look the same. So the reason that they've been so influenced by C is, of course, because C itself has been so successful. And again, it's what we were talking about earlier. Yeah, the popularity in programming languages comes somewhat from functionality and what they can do, but it also comes from a network effect. And so because you want to attract programmers to your new language, you adopt a syntax similar to C so that they have something right off the bat that they're comfortable with.
Let's talk a little bit about the culture of C. This is something I find really interesting about programming languages. How would you describe the culture?
So if you were learning programming in the 1980s or 1990s, it's very possible you would learn in Pascal, but it's also very, very possible you would have learned in C. That's not so much the case today. Today, languages like Python and Java and JavaScript are much more commonly used as first programming languages and as intros. And that's because they have a little bit less sharp edges for a new programmer. C allows you to directly manipulate memory. It allows you to kind of shoot yourself in the foot much more easily than a programming language like Python or Java or JavaScript. So C has kind of fallen out of favor as a teaching language, certainly as a first language for teaching. That doesn't mean it's not being used anymore. Of course, because it's used in so many places like we described earlier, libraries, operating systems, device drivers, implementations of programming languages, sometimes in apps, but not as commonly as those other three we just mentioned. It still is an important language for most programmers to know. So most programmers, even if it was in their first language or what they learned in college, will at some point learn C. And they will probably not use it on a day-to-day basis in their job, right? But they're probably still going to run into code once in a while that interfaces with a C library, or that code that can be further optimized if they rewrite it in C, which sometimes you need to do. C is not as popular as it was 20 or 30 years ago, but still a lot of people who are into kind of low-level programming, people into writing operating systems, people into writing system libraries, they're going to be working in C. And so there's still this kind of culture that's becoming a little of an older crowd, I would say, almost. When you talk to younger programmers today, it's less likely they're working in C. And when you talk to older programmers, it's more likely they're working in C. So I think there's becoming a little bit of a generational divide. And because C++, and to a lesser extent Objective-C, replaced C in many places, as did other programming languages, it seems that C is now more and more kind of going against the grain when you choose to write something in C instead of using one of these more modern languages. Now, there's also a bit of a divide between people who favor languages with a lot of different features and people who favor languages that you can really keep entirely in your head. So, for example, C++ is sometimes called a kitchen sink language because it just has so many different features. There are so many different things you can do with C++. There's so many different ways you can program with C++, and there's so much different syntax for you to be knowledgeable about. On the other hand, C has been so stable, as we talked about earlier, that once you learn it, you really know it. And there's not much about C that's going to change, and you can learn everything about it much more quickly than you can learn everything about a language like C++. So there's also a divide between programmers, those who prefer more simple languages and those who prefer having every possible feature available to them. Now, this is playing itself out in newer language communities as well. For example, the original creators of C, some of them, and some of the people who are involved in its original development, developed a newer language at Google called Go. That language came out in 2009. And Go is directly a response to C++. While C++ has continued to evolve since the 1980s, and like I said earlier, add more and more features, Go was explicitly designed to be closer to C in the sense that it's a much more simple language. It only has 23 keywords, in fact, so that it would have more stability and actually be more simple to parse and learn for programmers. So there's actually like a reactionary element against the complexity of some newer languages, which leads to some even newer languages coming out that are more in the vein of C, with this stability and simplicity in mind. So I think how C has impacted the culture, well, sure, there's all the languages that have been influenced by it. And I think if you think about almost any modern language, it's going to have somehow been influenced by C. But then there's also this whole idea of having a relatively simple language that's relatively close to where the machine's at, that has high performance, that is actually against the grain of where some languages have been going. And so there are language communities that are more on the C side, which is kind of like Go, let's say. And then there are language communities that are more on the C++ side, which might be something like, let's say, Swift today, which seems to continue to get more and more features added to it as a language.
Is there anything else our listeners should know about C?
Well, we mentioned earlier how a lot of programming languages are actually implemented in C. For example, the Python interpreter is implemented in C, the most popular version of Python, the CPython interpreter. And it also turns out that a lot of libraries for other languages are also implemented in C. Again, because C provides such high performance and it's so close to the metal in terms of how it can be converted into machine code and really operate quite similarly to how it was written. So if you use some very popular libraries from Python, for example, NumPy is a popular numerics library, and SciPy is a popular scientific language, they will often have large parts of themselves be written in C for performance reasons. So you might really be using code written in C even if you're working in another programming language, because they wanted to squeeze out every bit of performance for that particular library or that particular bit of code.
So there's a lot of C happening behind the scenes.
There's C is everywhere. C is just, it's below everything going on in your operating system, even if the higher level parts are written in other languages. It's below what's going on in your programming languages, and it's below what's going on in a lot of libraries being used. So C is really the basis of all modern computing. All right, well, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPEC EXPLAINS.
And we also want to remind everybody to subscribe. We've been seeing some great growth in subscribers recently, and we want to continue that. So if you like episodes like this, and we do different kinds of topics all the time. Sometimes we do a particular app and we talk about its history. Sometimes we talk about something like technical, like a programming language. And sometimes we talk about just general computing topics that we have a bit of a discussion about. So if you want to get this great variety that we're delivering, please subscribe. You can click follow on Spotify or click the subscribe button on Apple Podcasts or Overcast or your podcast player of choice. And we'll see you next time.
Thanks for listening.